Good morning. Our senior project is an intubation training system. We are Katya, Meredith, and Rabab. We are working with Mr. Paponis and Dr. Joseph Kutcher in collaboration with the simulation lab at St. John Providence Hospital.
Some statistic in the problems includes there are about 50 million intubations procedures globally each year, and of them, almost 97% lead to some form of injury. These injuries can be in a range from minor bruises to large lacerations. Research on this has also shown that proper training and experience can reduce changes in injuries, especially the lacerations.
A majority of medical professionals utilize a medical dummy and laryngoscope during intubation training, which doesn't provide any feedback to the user. Another current technology for intubation training is shown here. The sensors embedded in the laryngoscope blade provide force quantification, but fail to provide adequate feedback. We created a new technology in order to address the lack of proper intubation training products on the market today. The goal of the project is to design a training tool for inexperienced medical professionals to teach them the proper intubation technique so they do not cause injury to the patient's mouth, throat, or teeth. This tool should be able to measure the forces placed on the intubation blade during training, provide feedback when the injury threshold is reached, and allow users to track their progress towards an ideal intubation technique. The final device is shown here. It is 3D printed and has two FlexiForce sensors on the distal end, connected to an Arduino. The sensors are positioned where the most force is placed upon the blade. The 3D printed design was used because it is easy to manufacture and the device is only meant to be used on medical dummies, so the ability to sterilize the device was not a decision factor. The laryngoscope has a Macintosh-style intubation blade. This design was chosen because it is widely used by doctors. There are two feedback systems for the user, a real-time feedback system in the form of a buzzer and a post-procedure feedback system in the form of an app. When we were choosing the most appropriate real-time feedback system, teaching effectiveness and amount of information given were the top priorities. The auditory feedback was more useful than the visual feedback. The information displayed on the app used to give post-procedure feedback was decided on using ease of understanding and amount of data provided as the main criteria. A graph displaying force over time, a score for both the current and previous trial, and recommendations for improvement are provided on the app. The score is based on the duration of intubation procedure and the force applied to both sensors.
This animation shows how our device works. For training, the user needs an intubation dummy, an endotracheal tube, our device, and a smartphone with our app installed. This is the app home screen. The user clicks the Begin Testing button and is moved to the user screen. Here they click the Connect Bluetooth button to connect the phone to the device. When connected, the connection button will turn green and the device box will light up. The user will then select their name and move to the testing screen. Then they click the Start button and begin intubating. During the intubation, the app shows the force on each sensor, the elapsed time, and a time versus force graph. The box will make a sound if the injury threshold on the force sensor is exceeded. When the intubation is complete, they press the Stop button. They can visualize the graph for 30 seconds before moving to the final screen. This screen will show the user's score, previous score, and recommendation for improvement. The user will then click the Return button to go back to the main screen.
Now I will go into some of our important results from our project. These are the results from our feedback testing. During prototyping, we did not know whether an auditory or visual feedback system would be most effective during the intubation. Therefore, we tested both types of systems with students at LTU. This figure shows that the students rated the auditory and combined auditory and visual system as the most useful. However, we determined that the auditory alone was the best for our final design because 53% of participants said they could not focus on the intubation and look at the lights at the same time. The results here on the right show baseline fluctuation testing, which was a major problem during the feedback testing at LTU. The results show that the low-pass filter helped to eliminate baseline fluctuation, allowing the device to make more consistent and accurate force measurements. The data on the left shows our market research. With over 500 simulation labs in the U.S., each with many simulation dummies, there is a mid-sized market for our device. Given its low price compared to the cost of other equipment in the simulation labs, our product could be readily incorporated.
In the future work, we need more tests with medical professionals to improve sample size and thus confidence on our results. We have done control testing of the solution, so beta tests with medical professionals on different things like user interface, sensor function, thresholds can provide better results.
Our references are provided. Thank you for your time.